Now we have the simulation result, and now we will explore the different post-processing methods. So the first one is to plot the streamlines. So we want to see how the flow develops through the streamlines. In order to do it, we should go to derived parts. So here is one I generated earlier. So in order to demonstrate, I just delete this one. Okay, so we go to the derived parts and right click, new part, and we'll see the streamline. Okay, so here is a window. We need to do some settings. So the input part is a region we have. So if we can have a look. So this is a region. The entire simulation region should be selected. Okay, and then the seed mode, and there are different modes. So first is point seed, which means we have only one point as a seeding point, and then the streamline will start from that point. Or line seed, so the seeding are located along a line. And also part seed, usually it's a service or several services. In here, we will try to use a part seed, and so the part should be the inlet, for example. So we just choose the inlet in here, under the boundaries folder, and we OK. And in here, because it's an inlet service and the resolution is in X direction, and in here is Z direction, 5 points, and Y direction and 5 points. So in total we have 25 seeding points, and then we will get 25 streamlines. If you want more streamlines, you can increase the numbers in here or resolution in here. And a vector view, because we're plotting a streamline, so it's a velocity. If we want to plot the vortex line, this can be changed to vorticity. Yeah. And we will display it as a new streamline displayer. And OK, we just create, and you will see the streamlines are here, and it can be seen. Then we close it. So all the streamlines are here, and if you count, there are a total of 25 streamlines. Especially the lower one is more interesting. So underneath it's a recirculation bubble, and the flow, the streamline follows the curvature of the separation bubble. Okay, so if we now go to the Scene Plot tab, and we will see a streamline. And so because the scalar plot in the center plane is still showing, we double click, can disable it. So now only the streamlines are shown. Okay, and also there are several other things we can do. If we click the scalar field, and what I want to do now is to color code the streamline. So if we go to the scalar field and choose a function, for example, for now, I want to choose velocity magnitude to color code the streamlines, so we can see and how along the streamline, how the velocity on the streamlines, velocity magnitude actually. And this is how we use streamline as a post-processing method. And so this is a very basic one. We're using the existing service or existing phase, and for example, the inlet service in here. And the question is, we can't see the recirculation bubble. In order to visualize the recirculation bubble, then we need to create a phase or surface within the flow fields, right? For example, in here, then the seeding will be located within the separation bubble. So let's do that. Okay, what we can do is to disable this one, disable the streamlines, and we create a new one. But before create a new streamline, we need to create a surface at the beginning. Still, we need to go to the derived parts, and then we will create a section and a plane. Okay, so just roughly we can drag this surface and so now we're changing the orientation in order to make it better. So I just type 0 here and 0 here and 1 here. Okay, no, it's 1 0 0 and the origin, let's say 0.2. That is okay, the origin that is 0.5 meter and x is 0.5 and y is 0. So that's the origin of this surface, and we will play a new surface displayer we create. Okay, so we get an additional surface and we go to derive, and you will see this plane section 2 will be here. Okay, now we just create a new part, or we just change the setting of this streamline. Right, so we double click, or we change here the region, change a part, C type part. I think we need to change it in here. No. Our seed source, we can move the originally the seed source was at the inlet surface. Now we want to move it to this derived surface. Okay, so we just change it to here, plane 2. Right, so we have the signal plane. Still the resolution is 5 by 5. Now we should be able to see the streamlines, the new streamlines, and we can see the separation bubble now. Okay, yeah. Similarly, if we come to here, enable it, and we will see the velocity magnitude is color coded by the velocity magnitude. So this is how we generate streamlines as a post-processing method.